Hello and welcome to our second video going over our division of polynomials, or exercise 6B. If you're following along in the textbook, it's page 215. We went through this stuff on Monday, our last day of school. However, I feel like I didn't go through it as thoroughly as I would have liked to. Speaking of not going through something thoroughly, last video we went through the expanding something like a plus b, and then c plus d plus e. Now, I explained to you last time, apologies, I explained to you last time that you can actually expand it by saying a times c plus a times d plus a times e, and then adding b times c plus b times d and b times e. Now that works. It gives you an answer of ac plus ad plus ae. And then when we add the b, we get bc plus bd plus be. That works out perfectly fine. But the reason it works is because this is the same as, let's look back to this original equation. This is the same as if I was to write a times c plus d plus e plus, and then I write b, c plus d plus e. Now, if I was to expand that, I get ac plus ad plus ae, and then I expand the b part, I get bc plus bd plus be. Lovely. And you can see that this is actually the same thing. These two equations are the same thing. You get the same answer. So we can actually continue to do this for as long as as many terms as we'd like when we're expanding such polynomials. Now let's move on to long division with positive integers. Now, long division with positive integers gives us something to base our understanding of when we're actually working with polynomials. So let's say I have, for example, 274 divided by 13. Well, first off, we'll think to ourselves, how many times is 13 going to 27? Well, the answer is 2, right? Because 2 times 13 gives me 26, so I write 26 here. And it's implied it's a negative, so I take it away. Now the question is, 27 minus 26 gives me what? The answer is 1. So I write 1, I bring down the 4. And then the question is, how many times is 13 going to 14? Well, the answer is 1. So I write 1 here, end up with 1 times 13, which is 13. Once again, it's implied negative. And so from here, 14 minus 13 is 1. So my answer is 21 remainder 1. My dividend is what's was actually being divided. So in this case, my dividend is 24. So 274. My divisor is what I'm dividing by. In this case is 13. And my quotient is my answer. So my quotient is 21. Oops, let me do a better job. 21. And my remainder is what's left, 1. So looking from this diagram, you can actually see that 200, well, not diagram, sorry, let's work here out. You can see that 274 is the same as 13 times 21 plus 1. 13 times 21 would give me 273, and then the 1 gives me the 274. The 1 is the remainder. Or, if I was to write it in a different way, I can actually say that 274 divided by 13 is the same as 21 plus 1 over 13. All I've done is I've divided by 13 every time. So you can see here, we've got the division, and then I've got my answer, the remainder up here, and then my divisor. This one being my quotient. Lovely. Now let's apply that same understanding for our long division of polynomials. First, let's look at long division of polynomials dividing by a linear polynomial. Linear means straight, so we have something to the power of 1. So something like x power of 3, x minus 3, x plus 4, whatever it is. Let's use the example of x squared plus 7x plus 11, all divided by x minus 2. We know that's a linear polynomial because it's to the power of 1. So x to the power of 1 minus 2, blah, blah, blah. Okay, so now the same idea goes. So before we said, well, how many times does 13 go to 27? Same thing. So, well, same thing. So let's say x minus 2. How many times is that going to x squared plus 7x? Let's focus on the x. How many times is x going to x squared? Well, x times x gives me x squared. Perfect. So now I say, what's x times x? X squared. X times -2 gives me -2x. Now, like before, we have an implied negative. So x squared minus x squared gives me 0. So I can just write a 0 there if I want to. You don't have to. That's just to make things a bit clearer. It's positive 7x, so that's this part here, minus 2x. So what we get is 7x plus 2x, which gives me an answer of positive 9x. Lovely. Now I bring down the plus 11, and I get this. So let's get rid of the 0 plus, because that's not helpful. Okay, so now I've got 9x plus 11. Now the next question is, how many times does x, so this x over here, how many times does that go into 9x? Well, 9 times, all right, plus 9. And I say, well, 9 times x gives me 9x. -2 times 9 gives me -18. And I do this. Once again, it's an implied negative. So 9x minus 9x gives me 0. Well, I don't even have to write it. 11 minus 18 gives me 11 plus 18, which is 29. So my answer is x plus 9, remainder 29. If I was to write this using our understanding of what we got from up here, if we use that understanding, I can say that x squared plus 7x plus 11 is equal to our divisor, x minus 2, multiplied by our quotient, which is x plus 9, and then add the remainder 29. Or it's equal x squared plus 7x plus 11 divided by our divisor, which is x minus 2, is equal to x plus 9 plus our remainder over our divisor. So let me just label that. So this is my divisor. This is my quotient. Apologies for the messy handwriting. This is my remainder. And this is my dividend. Dividend. Okay. So that's how we solve a polynomial division by a linear polynomial. Let's try one with a non-linear polynomial. So a non-linear polynomial is anything to the power of besides 1. So it could be to the power of 6, power of 3, whatever it is. So let's use the example of, let's say, 3x squared plus 6x plus 13, all divided by x minus 2. Oh, and if you're wondering, this example is from page 217, and this example on the left is from page 215. Lovely. All right, let's go through this one. So it'd be, that's a linear polynomial. All right, let's change this up a bit. Let's change this up to b. This one is from page 219, and the example is 3x squared minus 2x squared. Sorry, that one should be a cubed. 3x cubed minus 2x squared plus 3x minus 4, all divided by x squared minus 1. Lovely. We know it's a non-linear because it's the power of 2. No longer makes it linear, makes it quadratic. So x squared minus 1 is the same as if I was to write x squared plus 0x minus 1. There's no difference. All I've written is 0, just to make my life easier. It's kind of like if I was to write 4.1 is the same as 4.1000. It's the same thing, just makes it more detailed. So let's go through it. So the first thing I'm looking at is, well, how many times does x squared have to multiply to get to 3x cubed? Well, the answer is 3x. So I write 3x, and x squared times 3x gives me 3x cubed. And then what the question is, what's 0x times 3x? Well, it's just going to be 0. So I end up writing plus 0, or I can write plus 0x squared just to make life easier. And I go through, and it's -1 times 3x gives me minus 3x. Awesome. Now, same thing, we implied negative, so we go through and do that. So 3x cubed minus 3x cubed gives me 0. Negative 2x squared minus 0x, this is negative 2x squared. 3x minus minus, now now watch out for the double negative, so that becomes positive. So it's 3x plus 3x gives me plus 6x. I bring down negative 4, I get minus 4. Now I have negative 2x squared plus 6x minus 4. The question becomes, what am I multiplying x squared by to get to negative 2x? Or in other words, what's the negative 2x squared divided by x squared? Well, that obviously gives me negative 2. So I write minus 2, and I get, well, negative 2 x squared. What's negative 2 times 0x? Let's just write plus 0x. And then minus 2 minus 1 gives me positive 2. Once again, implied negative. Negative 2x squared minus 2x squared is the same as writing negative 2x squared plus 2x squared, which gives me 0. 6x minus 0 is just 6x. Negative 4 minus 2 gives me minus 6. So my answer, the question is, does x squared go into x anymore? Well, no. So that is my remainder. This is my remainder. This is my divisor. And this is my quotient. And this is my dividend. So let's express our answer properly. So my answer, let's say x squared, 3x cubed minus 2x squared plus 3x minus 4 is divided by, now we can write plus 0x inside. So we've got x squared minus 1. We can write plus 0x, but that's just going to make things a bit messier. So let's stick with x squared minus 1. That equals to 3x minus 2 plus, now my remainder is 6x minus 6, but that has to be divided by my divisor, so x squared minus 1. Now, or we can rewrite this as 3x cubed minus 2x squared plus 3x minus 4 equals to x squared minus 1 times 3x minus 2 plus our remainder. Oops, there's no bracket there. Just to clarify, this is my dividend. This is my divisor. This is my quotient. And my remainder. All right. That is all for exercise 6B. If you have any questions, please let me know. I know there's quite a bit of content today. Hopefully it makes a bit more sense to you after watching this video. Feel free to pause it once again. And if you want, I'll upload the notes onto Compass so you can just copy it from there as well. Best of luck.